Hey folks, want to jump out here and do a quick solo podcast. This one's going to be on software. I know it can be quite a broad topic, so let's jump into it. Briefly over on Google AI Overview, software is a collection of instructions, data, or programs used to operate computers or execute specific tasks. As the intangible component of a computer system, it acts as an intermediary between the user and the hardware, directing the physical parts to perform actions. Key aspects, and the source there is www.softwareadvice.com.au. Key aspects of software, including there's three other sources. Time as well. IBM. Software itself is a set of instructional programs. Over on the website, software itself is a set of instructions or programs that tell a computer what to do. It is independent of hardware and makes computers programmable. The goal of software development is to create a product that meets user needs and business objectives in an efficient, repeatable, and secure way. Let's jump back into it. So, key aspects of software include types, primarily divided into system software, operating systems like Windows/Linux, and application software, programs like web browsers or Word. Purpose enables automation, information processing, and control of hardware functionality. Creation developed by programmers using programming languages to create executable code. Executable code. That's what I thought. Excuse me, it's a little bit later in the Friday evening. But we'll keep going. Distinction, unlike hardware, which is the physical, tangible component, software is intangible and can be updated. Common examples include operating systems, web browsers, productivity apps, word processors, spreadsheets, and games. And there is a simple definition of software. Software tells a computer how to work and what tasks to perform. It can be something small like a calculator app or something very complex like enterprise cloud software managing thousands of users at once. And it goes different types of software, examples of software. Microsoft Windows, OS, Google Chrome, browser, Microsoft Office, productivity, Adobe Photoshop, editing, and Spotify streaming, spanning desktop, mobile, and cloud environments. Common software examples by type. I think we've covered most of it. But yeah, let's go over to ChatGPT and let's get into the best, do our best today to cover software development as well. So if we go over to ChatGPT, quote, software, end quote, is a broad term that refers to the program's instructions and data, tells a computer what to do. Unlike hardware, the physical parts, or like your laptop, or phone, software is intangible. It's the code running on those devices. Main types of software, which we covered already briefly. Number one, system software runs the core functions of a computer. Examples, operating systems like Windows, Mac OS, Linux handles memory, hardware, and basic system tasks. Number two, application software, programs designed for users to perform tasks. Examples, web browsers, word processors, games, mobile apps. This is what most people think of as, quote, apps, end quote. Number three, programming software, tools developers use to create software. Examples, code editors, compilers, debuggers. Simple analogy, hardware equals body, software equals brain/instructions. Without software, hardware can't do anything useful. Let's get into software development quickly. Software development is the process of designing, building, testing, and maintaining software applications, basically turning ideas into working programs. What software development involves, at its core, it's a cycle of steps. Number one, planning and requirements. What problem are we solving? Who will use the software? What features are needed? Number two, design, structure of the app, architecture, UI, UX design, how it looks and feels. Number three, development, coding, writing code using languages like Python, JavaScript, Java, C++. Number four, testing, finding and fixing bugs, ensuring everything works as expected. Number five, deploying, releasing the software to users, web, app stores, etc. Number six, maintenance, updates, bug fixes, improvements. Types of software development: web development, websites and web apps, front end, what users see, plus back end, server logic, mobile development, apps for iOS and Android, desktop development programs like Word or Photoshop, game development, building video games, cloud and backend systems, servers, databases, APIs. Key skills, problem solving and logic, programming languages, understanding algorithms, debugging, version control like Git, common tools and technologies, editors, Visual Studio Code, IntelliJ IDEA, version control, Git, platforms, GitHub, frameworks, React, Django, Spring, development approaches, Agile, interactive, flexible development, waterfall, step-by-step linear process, DevOps combines development plus operations for faster delivery. Simple example, if you build a to-do app, plan users can add/delete tasks, design simple list interface, code, use JavaScript plus database, test, check for bugs, deploy, put it online, maintain, add features like reminders. Just a clear beginner roadmap for software development. Again, I'm not a technical founder in a startup, so this would be new to me as well. Keep it practical so you can actually start and not get overwhelmed. Beginner software development roadmap. Step 1, understand the basics. 1 to 2 weeks. Start with core concepts. What is programming? How code runs? Basic logic, if/else, loops. Recommend beginner languages. Python, easy to learn, or JavaScript, great for web. Step 2, learn your first language, 3 to 6 weeks if you choose Python. Variables, loops, functions, lists, dictionaries, simple scripts. If you choose JavaScript, variables, bracket let, comma, const, or I believe that's could be construct, const, end bracket, or const. Maybe I'm way off in saying that, but the abbreviation is const. In programming, the const keyword is a type of qualifier used to declare a variable or reference as immutable, unchangeable after its initial assignment. While its primary purpose is to define read-only data, its behavior varies significantly across languages and contexts. Key purposes of using: safety and prevention, readability, optimization, memory, efficiency. Let's go back to where we were. Functions, arrays, DOM basics for web, or DOM basics for web, DOM basics for web. Step 3, build simple projects, very important. Start small, calculator, to-do list, number guessing game, then level up, notes app, weather app using API. This is where real learning happens. Step 4, learn essential tools, code editor, Visual Code Studio, version control, Git, code hosting, GitHub. Learn how to save code with Git, how to upload projects with GitHub. Step 5, pick a path after basics. Option A, web development, most popular, HTML plus CSS. JavaScript, deep dive, framework, React. Option B, backend development, Python, Django/Flask, database, SQL. Option C, mobile apps, Java/Kotlin, or Kotlin, Android, Swift, iOS. Kotlin? Yeah, I think that's it. Okay, let's continue. Swift iOS, we talked about. Option D, other parts, game dev, AI/machine learning, cybersecurity. Step 6, learn deeper concepts, APIs, how apps talk, databases, store data, algorithms, and data structures, basic level first. Step 7, build a portfolio. Create 3 to 5 projects, personal website, full stack app, front end plus back end, one quote unique end quote project, host them on GitHub. Step 8, get job ready, learn debugging skills, practice coding problems, light level, understand real world workflows, realistic timeline, 1 to 2 months, basic plus small projects, 3 to 6 months, intermediate plus portfolio, 6 to 12 months, job ready if consistent. Honest advice, don't just watch tutorials, build things. You will feel stuck. That's normal. Consistency beats talent. If you want, tell me your goal, job, freelance, which we won't get into. Let's just add in AI before we go over to Gemini.google.com. We're nearly on 15 minutes. I'm sure we'll be okay. Adding AI into your roadmap makes you way more valuable, but it's important to layer it on top of programming fundamentals, not jump in blindly. I don't know if we'll talk about this too much. Software development plus AI roadmap. Let me go over to Gemini.google.com. Software in 2026 is defined by a, quote, rewiring, end quote, of how technology is built and used. We've moved past simple automation into a period of relentless reinvention where AI is no longer a bolt-on feature, but the very foundation of the software development lifecycle, SDLC. Number one, the 2026 macro trends. The industry has shifted from, quote, cloud first, end quote, to agentic and hybrid models. Software is becoming more autonomous, more secure by design, and more integrated into physical reality. Trend agentic AI, what it means for 2026. Software doesn't just wait for clicks. AI, quote, agents, end quote, proactively execute multiple step workflows across different apps. Vibe coding, natural language is becoming a primary programming interface. Developers describe intent, the, quote, vibe, end quote, and AI handles the implementation. FinOps and green software. With AI computing costs soaring, engineering now focuses heavily on energy efficient and real-time cloud cost management. Edge and hybrid AI to reduce latency and costs. AI is moving off the cloud and onto local devices on device AI and edge servers. Number two, evolution of software development. The way we build software has fundamentally changed. The barrier to entry has dropped, but the complexity of managing these systems has risen. Number one, intent-based planning, natural language specs. Number two, multi-agent orchestration, the AI. Number three, embedded dev spec ops, security at machine speed. Number four, observability and governance, human in the loop. Number three, essential software categories. For businesses and individuals, the, quote, must-have, end quote, stack in 2026 focuses on interoperability and data sovereignty. Composure, enterprise apps, progressive web apps, PWAs, data mesh platforms, privacy, pre-serving software. The 2026 reality, success in software today isn't about who can code the fastest. AI has made coding cheap. Success is about architectural integrity, how well you can orchestrate agents, secure your data, and control your cloud economics. Fascinating. Let's go over to Claude, see what they have to say. Doesn't seem to be loading. It's pretty slow. No offense to Claude. Let's go back over. If you have to understand one big idea about software and software development, it's this. Software is about solving problems, not writing code. Code is just the tool. What really matters is understanding a problem clearly, breaking it into small steps, designing a solution that works reliably. Think of it like this. Anyone can learn syntax, Python, JavaScript, etc. But good developers ask, what exactly is the problem, question mark? What's the simplest way to solve it? What could go wrong? Example, let's say you build a to-do app. Beginner thinking, quote, I need to write code for buttons in this, end quote. Developer thinking, quote, users need a fast way to track tasks without confusion, end quote. That leads to better design, simpler code, a more useful app. What separates beginners from real developers? Beginners focus on syntax, developers focus on logic plus structure plus users. The real skill, over time, you'll notice you Google less, you spend more time thinking before coding. That's when you're leveling up. Bottom line, software development is problem solving at scale. Fast. The same idea applied to AI, which we talked about briefly on episode 13. AI is still just problem solving, but using data instead of hard code rules. Traditional software versus AI. Traditional software, you tell the computer exactly what to do. And then, for example, Python, if email contains, quote, free money, end quote, mark as spam, you define the rules. AI-based software, you don't write rules, you train a model, feed thousands of emails, the model learns patterns, it decides what is spam, the system learns the rules itself. The big shift, software dev, logic-driven, AI dev, data-driven, but the core idea stays the same. You're still solving a problem. Example, same problem, two approaches. Problem, recommend movies, traditional way. If user likes action, show action movie. If user likes comedy, show comedy. Simple but limited. AI way, analyze user behavior, compare with other users, predict what they'll like smarter, more personalized. What beginners often get wrong, they think, quote, AI is about fancy models, end quote, but in reality, most of the work is cleaning data, choosing the right problem, making results useful. What makes a stronger AI developer, which is different, well, we'll keep going, not just knowing tools like PyTorch, TensorFlow, but understanding what problem actually needs AI, when not to use AI, how to integrate AI into real apps, the real mindset. Instead of, quote, how do we use AI here, end quote, think, quote, is AI the best way to solve this problem, end quote. Simple rule, if rules are clear, use normal programming. If patterns are complex, use AI. Final takeaway, AI doesn't replace software development, it extends it. You're still solving problems, designing systems, building useful things, just with smarter tools. And then we could talk about beginner AI projects that actually teach you spam email classifier, best first AI project, movie recommendation system, house price predictor, chatbot rule-based AI upgrade, image classifier, cats versus dogs, how to approach these important, best to order them. And then we'll talk about some of the best tools for software 2026, or we'll go back code editors slash number one, code editors slash IDEs. Your main workspace, these are essential for every developer to use. Cursor, Visual Studio Code, IntelliJ IDEA. Number two, AI coding tools, biggest trend in 2026. GitHub Copilot, ChatGPT, OpenAI Codex, Tabnot. Number three, version control, non-negotiable. GitHub, GitLab, that's what it says. And then we'll just go back. Project, team tools, Trello, Slack, Jira. DevOps, number four, DevOps, which is before and developing tools, Docker, Jenkins, Kubernetes. Number six, testing and debugging tools. Number seven, API and backend tools. Biggest trend in 2026, AI is changing everything. AI can now write email features, new quote agents, end quote tools can handle full workflows. Developers are shifting from coding to rewriting AI generated code. We briefly talked about this, but we'll just go over it one more time and then we'll go back to the one big thing. AI isn't a separate field sitting next to software development anymore. It's embedded throughout the entire development process, which we briefly talked about. Where AI fits into software development, number one, writing code. Tools like GitHub Pilot and ChatGPT help generate functions. And then number two, debugging and understanding code. Number three, design software architecture. Number four, testing and quality assurance. Number five, building AI-powered features inside apps. Number six, automation, workflows, DevOps, the big picture, the mindset we already talked about. So yeah, let's go back to the one big thing about software and software development, which we talked about. Software is about solving problems, not writing code. Code is just a tool. What really matters is understanding a problem clearly, breaking it into small steps, designing a solution that works reliably. Think of it like this. Anyone can learn syntax, Python, JavaScript, etc. But good developers ask, what exactly is the problem? What's the simplest way to solve it? What could go wrong? Example, let's say you build a to-do app. Beginner thinking, quote, I need to write code for buttons and lists, end quote. Developer thinking, quote, users need a fast way to track tasks without confusion, end quote. That leads to better design, simpler code, a more useful app. What separates beginners from real developers? Beginners focus on syntax, developers focus on logic, plus structure, plus users. The real skill, over time, you'll notice you Google less syntax, you spend more time thinking before coding. That's when you're really leveling up. Bottom line, software development is problem solving at scale using code. Thanks for listening, folks. Feel free to follow along, leave a review, or subscribe if you're getting some value from the show. And have a great rest of your day.